Sometimes we choose to use a common unit instead of the standard international unit. A good example of this is when we measure temperature in everyday life. We don't usually use Kelvin, which is the SI unit. Instead, we use degrees Celsius. But in science, we do tend to try to rather use the SI unit. So to tell the difference between temperature measured in degrees Celsius and temperature measured in Kelvin, we often use the symbol small t for temperature measured in degrees Celsius and capital T for Kelvin. But this can be a bit confusing, of course, because you should remember that small t is also the symbol of time. Some properties use SI units in a specific way. For example, period is a kind of time, and it uses the unit, the SI unit, seconds as its unit. So to show the difference between the general property of time and the specific property of period, we use a small t as a symbol for time and a capital T as a symbol for period. Notice that again we're using capital T's and small t's as we did with temperature just now. So symbols are not always self-explanatory because we can sometimes use the same letter, the same symbol for a number of properties. So you have to then see from the context which one we're meaning. So period means the time for one thing. For example, the time for one wave to pass a point. And if we're speaking about that, we're speaking about a particular kind of time. So we don't just use a small t as for the general use of time, but a capital T meaning specific use of time, the time for one occurrence. Similarly, wavelength is measured in the SI unit meters, and it's a particular type of length. It's the length of one wave. So we don't just use the general symbol L for length. We have a specific symbol, which is the Greek letter lambda, the Greek letter L, which you write like this, and that means the length of one wave. The property frequency means how many per time. For example, how many waves pass a point in 1 second. The SI unit for measuring time is seconds, and the inverse of that is per second. And per second is the same as hertz. Quite a number of units that we use in science are derived from 2 or more SI units. Let's look at some examples. Area means flat space. Its symbol is A, capital A, and its unit is meters squared. Volume is 3-dimensional space, capital V, meters cubed. Density means mass per volume. Its symbol is D. It's measured in the unit grams per centimeter cubed. Now those aren't using SI units. In SI units, that would be kilograms divided by meters cubed, which is 1,000 grams divided by 1,000,000 centimeters cubed. Concentration means the number of moles per volume. Capital C, moles per centimeter cubed. If we were to write that rather in the SI unit, it would be moles per meter cubed. Notice moles per meter cubed doesn't mean the same as moles per centimeters cubed. They're not equivalent. And the kinds of concentrations that we usually use in our laboratories lend themselves better to be described as mole per centimeter cubed than mole per meter cubed. They give better numbers if we rather use the non-SI form of the unit. Velocity means how fast. The symbol is V, and it's measured in meters per second, which can also be written as m dot s to the minus 1. That dot means multiply, the minus 1 means inverted. In other words, meters multiplied by the inverse of seconds, which is the same as meters over seconds, meter per second. Acceleration means how velocity changes, the rate of change of velocity. Its symbol is A, and its unit meters per second squared. Force means push or pull. The symbol is F, and the unit is newtons. A newton is the same thing as a kilogram meter per second squared. Notice that kilogram, meter, and second are all SI units. So a newton can be written directly in SI units. It is actually already written in SI units. It's just that it's quicker to write an N than to write kilogram meter per second squared. So that's why we just save time by writing the N. But the N means kilogram meter per second squared. Pressure means force per area. Its symbol is a capital P, and its unit is pascals. A pascal is a Newton per meter squared. So we can see that that is also actually written in SI units, because a Newton means a kilogram meter per second squared, and we're dividing that by meters squared to get a pascal. So the meters, 2 meters cancel out, leaving only 1 at the bottom of the fraction. So a pascal is actually a kilogram per meter per second squared. Energy is the ability to do work. Symbol E, unit, joules. A joule is the same as a Newton meter. Remember, a Newton is a kilogram meter per second squared. Multiply that by meter and we have kilogram meter squared per second squared, which is the same thing as a joule. Power means the rate at which work is done. Its symbol is a P. Its unit is the watt. Watt is written shortly as a W. A watt is a joule per second. Remember that a joule is a Newton meter. So a watt is a Newton meter per second. Remember that a Newton is a kilogram meter per second squared. And so a Newton meter per second is a kilogram meter times meter divided by second squared and again divided by seconds, which gives us altogether kilogram meter squared divided by second cubed. Or we can write that as kilogram meter squared second to the minus 3. All of that means the same thing as a watt. Obviously, it's a lot easier to write just a plain W, so that's why we do it. But in fact, the watt is written in terms of SI units. Charge means how charged something is. Its symbol is a capital Q. Its unit is the coulomb, capital C. A coulomb is an amp second. Both amp or ampere and seconds are SI units. Voltage means energy per charge. Its symbol is a capital V, and its unit is also called V, volts. A volt is a joule per coulomb. So we can write that in terms of SI units by remembering that a joule is a kilogram meter squared per second squared, and a coulomb is an amp second. So here we have a fraction divided by another fraction, and we tip in times, and from that we get kilogram meter squared divided by amp second cubed. So that is a kilogram meter squared amp to the minus 1 second to the minus 3. I think you can see very clearly why we rather just plain write V for volts. Resistance means how difficult it is for charge to flow. The symbol is a capital R, and the unit is the ohm. An ohm is a volt per amp. Now remember that a volt is a kilogram meter squared per amp per second cubed, and we divide all that by an amp. So we've got a fraction divided by another fraction, amp over 1. We tip and times the bottom fraction. So we get kilogram meter squared per amp squared per second cubed, which we can also write as kilogram meter squared amp to the power minus 2 second to the power minus 3. Obviously, a lot easier just to use the symbol omega, which stands for ohm. Test whether you've learned what you needed to learn in this lesson by answering these questions. Pause the movie while you do this on your own, and then you can see the answers.